In this video, we're going to cover a couple extra examples in Lesson 7.2. We are on your Supplementary Notes page, or Supplemental Notes page for Lesson 7.2. So make sure you have that out in front of you so you can follow along. In the first example, we need to find the coordinates of the intersection of the diagonals of parallelogram LMNO with vertices L14, M74, N60, and O00. So essentially what we are trying to do is we are trying to find, okay, what are the X and Y coordinates of this point where our diagonals intersect? And so what we know about diagonals is that they bisect each other. Well, if they bisect each other, that means this point is the midpoint of segment O and this point. I'll just call it, I'll call it point T. So this point is the midpoint of segment OM, and this point is also the midpoint of segment LN. And so what we can do is we can find the midpoint of both diagonals, which they should be the same, and that point will be our point T here that we're trying to find. So we're going to find the midpoint of these diagonals. So we're going to need the midpoint formula. That's why it's at the top of your notes page. Let's find the midpoint of segment OM. Okay. So here's our work to find the midpoint of segment OM. We need to use point O and point M in our midpoint formula. I'm going to go ahead and label these X1, Y1, X2, Y2, and I'm just going to plug them in. So X1 plus X2 will be 0 plus 7 divided by 2. Y1 plus Y2 divided by 2 will be 0 plus 4 divided by 2. Now when I go ahead and I add and divide, I get 7 halves. I'm going to keep it as a fraction. 0 plus 4 is 4, and 4 divided by 2 is 2. So this point should be located at 7 halves 2. But what we should do just to double check our work is find the midpoint of the other diagonal, and it should be the same. If it's not, that tells us our work may be wrong somewhere. So let's go ahead and find the midpoint of diagonal LN. So this time I'm going to label this X1, Y1, X2, Y2. Oops. So X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. I'm going to go ahead and simplify this. 1 plus 6 is 7, and 7 over 2, I'll leave that as a fraction. 4 plus 0 is 4, and 4 divided by 2 is 2. They check out to be the same, so this intersection is located at the point 7 halves 2, and that's my final answer. In this last example, it says 3 vertices of parallelogram WXYZ are given, and here they are. And we need to find the coordinates of vertex Y. So I can kind of tell that point Y is going to be somewhere over here in this quadrant in order to make a parallelogram. And what I need to, the property I need to use to answer this problem is that I know that opposite sides of parallelograms are parallel. And we have learned in the past that parallel lines have the same slope. Okay. So what we can do is we can find the slope of the segments we do have to help us find where that other point needs to be so that the slopes of the opposite sides are the same. And I just do this using the graph. And so remember, you have a slope formula, but I also like to think of slope as rise over run. And so as an example, I'm going to go ahead and find the slope of segment XW. All right, so I'm just going to count the rise over the run. So I'm going to start with the point on the left and count to the point on the right. The rise is down 1, 2, 3, 4, 5. So it's down 5. The run is right 1, 2. So the slope of segment XW is equal to negative 5 over 2. And so what I can do is I know that the slope of the line segment that it's opposite to also needs to have a slope of negative 5 over 2. And so what I do is I start at this point and I kind of count that slope backwards. So I'll count 2 to the left and 5 up to get a slope of negative 5 over 2. So I'm going to do the same thing over here, just kind of in reverse. So I'm going to count 2 to the left and 5 up, which means my last point should be located here in order to have that overall slope of negative 5 over 2. So I think point Y is located at positive 2, positive 1. Now, a way to check our work is now, if this is where point Y is, does that make these two sides have the same slope? Remember, because opposite sides should have the same slope. So let's find the slope of WZ. Rise over run. Down 1. Right 1, 2, 3, 4, 5. So the slope of WZ is negative 1/5. Well, that means the slope of XY should also be negative 1/5. So I can count to see if that's true. Down 1, right 1, 2, 3, 4, 5. That has the same slope as WZ. So point Y must be located here at the point 2, 1.